Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. When ML teams try to run complex workflows through traditional orchestration tools, they hit walls. Cash App discovered this with their fraud detection models. They needed flexible compute, isolated environments, and seamless data exchange between workflows, but their existing tools couldn't deliver. That's why Cash App relies on Prefect. Now their ML workflows run on whatever infrastructure each model needs across Google Cloud, AWS, and Databricks. Custom packages stay isolated. Model outputs flow seamlessly between workflows. Companies like Whoop and 1Password also trust Prefect for their critical workflows, but Prefect didn't stop there. They just launched FastMCP, production-ready infrastructure for AI tools. You get Prefect's orchestration plus instant OAuth, serverless scaling, and blazing fast Python execution. Deploy your AI tools once, connect to Claude, Cursor, or any MCP client. No more building auth flows or managing servers. Prefect orchestrates your ML pipeline. FastMCP handles your AI tool infrastructure. See what Prefect and FastMCP can do for your AI workflows at aiengineeringpodcast.com/prefect today. Unlock the full potential of your AI workloads with a seamless and composable data infrastructure. Pruning is an open-source framework that streamlines integration from the command line, allowing you to focus on what matters most, building intelligent systems. Write Python code for your business logic and let Pruning handle the heavy lifting of data movement, lineage tracking, data quality monitoring, and governance enforcement. With native support for ML and AI workloads, Pruning empowers data teams to deliver faster, more reliable, and scalable AI solutions. Harness Pruning's connectors for hundreds of platforms, including popular machine learning frameworks like TensorFlow and PyTorch. Build end-to-end AI workflows that integrate seamlessly with your existing tech stack. Join the ranks of forward-thinking organizations that are revolutionizing their data engineering with Pruning. Get started today at aiengineeringpodcast.com/Pruning, and for dbt Cloud customers, enjoy a $1,000 credit to migrate to Pruning Cloud. Your host is Tobias Macy, and today I'm interviewing Vinay Kumar about strategies and tactics for gaining insights into the decisions of your AI systems. So Vinay, can you start by introducing yourself?
Hey Tobias, this is Vinay. Pleasure being here. My name is Vinay Kumar, as you introduced. I'm the founder CEO of Arya.ai. We were one of the first deep learning startups, started in 2013. Currently, we have established a frontier AI lab called Lexsi Labs, which is in Paris, London, and Mumbai. We do a lot of frontier work around AI interpretability and alignment. So looking forward to discuss more in the conversation.
And do you remember how you first got started working in the ML and AI space?
Oh yeah, so this is almost 12 years back now. Started off in 2013. So this is actually an extension to my research at that time. So way back in 2013, so my problem statement was to build an AI system around continuous manufacturing. So I was exploring classic machine learning at that point of time. 2013 is very initial phases of AI and deep learning. I stumbled upon the deep learning papers at that point of time. The AlexNet paper, which was kind of getting a lot of buzz at that moment, that got excited us getting into just starting with AI to begin with as part of my academic thesis. Later on, I was very excited about what this can expand into. So that's how I started Arya.ai along with my co-founder. Initially, the problem statement was to build an intelligent assistant to researchers. We thought the search was dumb at the moment at that time. Like for researchers, if you remember, we were using things like Scopus or Google Scholar, which was simply keyword search. They were not doing anything smart at that point of time. And we know that there are so many papers that we have to go through before we can finalize the topic or the literature that we would have to go to. I thought it would be really, really interesting to have some kind of AI assistant that would have read all the papers and that can become my special professor or assistant to me that can help me to do my research. So that's how we started. This is extremely early phases of deep learning and AI. So since then, it's been 12 years. I only see that problem getting solved 3 years back with ChatGPT, I guess. So time does evolve. Yeah.
And so digging now into some of the focus on the interpretability and analysis of the decision-making process of these models, Before we get too deep in the weeds there, I'm just wondering if you can give your definition of the term explainability and, even more relevant these days, alignment in that context.
Got it. Again, so this is primarily our learnings that we have. We were kind of constructively now very clear. At the time was about 4 or 5 years back. So we have been deploying complex AI models, like in some cases using deep learning for a very mission critical problem statements, like in insurance underwriting, in banking, for example. We had a discussion with the head of business at that time. So this is probably 2019, 2020, where we used deep learning to build an underwriting model, and we were showing that the model works really fantastic. Then there were a bunch of questions for obvious reasons. One, they have to justify to the regulator in terms of how the system is making these decisions, and then also for themselves to get the confidence in terms of how exactly is the model able to predict. So this is when we were using sparse or readily available methods like sharp and line at that time. But we realized very quickly that so none of these methods are good nor accurate nor true to the model, meaning sharp line. So these are necessarily used as approximations to try to expect or predict how the model is functioning. But again, that is very much dependent on the hyperparameters, like what was your baseline and number of iterations, which means you're not necessarily explaining the model. You're simply building some fake parallel model to try to give some kind of explainability. It became very clear for us at that time. So we were like, okay, this looks like a problem. Meaning, I'm very confident to build very complex systems. If I do not get it accepted by the end user, then there is no point, right? Meaning, I can build more and more complex systems, which is more accurate. But if it is not interpretable, then it will never scale. It will never get into full potential. So we get started on that problem in terms of how do we do that. And at that time, alignment was not a big problem because the models were a little less complex, very definitive. So this is way back in 2020. In 2021, we came up with a technique called DL Backtrace, which is called deep learning backtrace. It's a new method to try to interpret deep learning models. We filed a patent in 2021. It was not released in public at that time. So what it does is it can able to trace back the relevance of the prediction back to your entire network and back to your input. It doesn't require any retraining for a specific model. It works for any kind of deep learning architecture, including LLMs as well. So it was a good innovation and creation at that time. But later on, once models are getting bigger, larger, massive, meaning our, again, going back to our thesis and goal, right? So we want to build systems which are interpretable, acceptable, and safe to scale, because we primarily work in very mission critical, highly regulated industry. So as when these models are getting complicated and complex, we realize that guardrails or risk policies are never going to scale, or is not, it's very hard to impose them on a model. Meaning currently, if I want to make a system safe, people do very outside the model applications, like applying some kind of guardrail, applying some kind of rule or a risk policy, for example. But there are now enough examples to say that these can be jailbroken, this can be tweaked, and this cannot be scalable at the moment. So this is where things get really complex, and we realized that again very early on in 2021, 2022. We realized that the models are getting complex. If we have to scale them to a very large volume, one, interpretability is one part. Second is the alignment, meaning alignment can be defined as the ability to able to deliver or make sure the model is within the business requirements or within the user requirements, to be very broad. It could be societal alignment, it could be bias alignment, it could be risk alignment or a safety, it could be any kind of alignment factor, right? So how do I align these models? So that's pretty much is kind of made us to realize that so these are the two problems that are very hard and quite important to solve if we have to make AI accepted or scalable to all set of users, not just to a limited number of use cases, which is what the current problem is, right? I may have a very complex system. If I don't scale these two things, it will still remain in a lab, it will still remain to a very low set use cases. It will simply become like a very underutilized capability or a technology. So that's pretty much is how it became the main theme for our lab in terms of how we want to get to, let's say, super intelligence or a safe intelligence. We want to make sure these are interpretable and aligned when we get there.
And so you dug a little bit into the DL Backtrace library. You mentioned Shapley values. I'm wondering if you could just talk a little bit more about the predominant methods that teams rely on for being able to gain insight into the ways that their models are operating, and particularly as we move into a realm where these foundation models are the majority stake for interaction with AI capabilities, how that changes the ways that we think about what the model is doing and the types of measurements that we need to do to ensure that we're getting the desired outcome from those models.
Interpretability is very much, or explainability. So, interpretability is technically from a model point of view. Explainability is more from a user point of view, right? Meaning, how do you explain a model to, let's say, a business user versus a regulator, for example? That's a different story. So, it all depends upon who the user is, right? Or at least it all very contextually starts with who the user is to begin with, from what does interpretability or explainability means to them. In fact, we have released a paper around few months back, which is our ability to standardize explainability and explainability evaluations is paramount to achieve AI governance. Or else, what happens is people have been using these gaps in the model, in the technology, to able to tweak their agenda and their point of view as the model's point of view. Meaning, model could be biased. I can hide it today. If we even if you use things like sharpen line, I can do scaffolding attack and I can show that model is not biased, right? And likewise, model could be racist. Model could be doing very abnormal behavior, but I can hide it because I am the one who is giving you the explainability, and there is no way to benchmark it. It's very much hypothetical to the user. So these are exactly the problems that we have seen with the current methods. Now, so what are these methods, right? So it all again, it's very much a model technique dependent. For example, if you're using classic machine learnings, like let's say gradient boost methods, for example, so they are intrinsically explainable to some extent because I can look at the tree and exploit the tree for each prediction, or at a global level for the entire model. So for classic machine learning systems, there are methods to do it. But again, these are not, if you use things like sharp and lime, so people have realized that they have been exploited, they're not good. And there are other methods like surrogate methods, like contrastive explanations. It doesn't actually explain the model, it only explains the boundary conditions of the model. You have contrastive explanations, and then you have prototypes as explanations. Again, it tries to dwell into how the model is working, but again, it's in the point of a group categorized data to tell you that this category of data is what made the model to predict this outcome. And then you have more nuanced ones like gradcam, you have integrated gradients, for example, when it comes to deep learning models, where you track or trace the activations or gradients and say, okay, find this neuron as activated in so and so manner, so which you can plot back to the input to say, okay, these edge features are responsible for classification and all that stuff. So the interpretable methods are very much dependent on modeling technique. Let's standardize that to deep learning, because deep learning is now a common theme even in LLMs at the moment, for example, right? So I could use, let's say, sharp and line even in deep learning. I could use IG, gradcam, smooth grad, these kind of methods if it is a deep learning model. But again, the problem is how scalable are they when the model grows in size and complexity and quantum from that point of view, right? So let's say if I'm using something like an LLM, so what method can I use to interpret, and what am I interpreting in that case, right? So people typically use activation maps to try to explain how the model is functioning for an LLM, because activation maps are anyways generated during inferencing, so it's easy for me to plot them and show that these are the layers or neurons which activated more when this prediction happens. But the problem is it necessarily doesn't say anything, meaning these neurons are activated, but it doesn't say is it positively influencing or negatively influencing. There is no contextuality. You just know that these neurons were activated from that point. So again, so this is not fully interpretable or helps me to interpret the model functioning. Then the methods came, which is SEs, sparse autoencoders, which is something which has been promoted or established by Anthropic's team, Anthropic's interpretability team. So where you train a model basis on these activation values, you create a surrogate autoencoded model. But again, you have to train the autoencoded model separately, right? Which means if your model is bigger, then you will generate a humongous amount of data, and you need a large amount of compute to able to generate an SE model. They are able to interpret in terms of how the model is functioning, which is what mechanistic interpretability was. to figure out which neuron is working in what direction. They were able to use that information for various things like model steering, for example, meaning if I know which neurons is inducing this behavior, can I use that knowledge to steer the model outcome such that I can have desired behavior inside the model, for example. So they try to use SAEs, but the problem is the scalability. And then there is circuit discovery as well, which is again has similar problems of scalability. So there are different methods, but all of them either has some kind of gap in terms of scalability or truthfulness or what it can do to explain the model interpretability. Nothing is right, nothing is wrong, except some few things are absolutely bull and gaslighting anyways. But some advanced methods like SAE, circuit discovery, and relevance based methods like what we introduced, or LRP, for example, which is very close to us, are nearly trying to do that job well enough. But now the question is the scalability, and is it model agnostic? Is it model specific? Is where it can get really interesting. So that those are the areas where we do a lot of research. Those are the areas where we do a ton of work around how do we scale it, what is required to scale it up, how is it computationally intensive, is it inferencing in real time, meaning explainability in real time as speed as inferencing, or is it going to take a time, how long would it take, those kind of stuff.
And so the utility of explainability is obviously that it helps you understand more about whether the model is doing what you think it should or whether it is working in the way that you designed it to. And I'm wondering if you can talk to some of the stages of the overall model lifecycle and serving lifecycle where you would incorporate these workloads of doing the generation and analysis of these metrics to understand what is the model doing and how.
Got it. So actually, so interpretability is started off from a direction where we want to understand the model, which is, for example, to begin with, let's say, okay, fine. So I build a model. The model works really well from an absolute qualitative accuracy metrics or performance metrics. But is it actually the same when the model is functioning? So there is this classic example, which was classifying wolves versus dogs, I think, in one use case where the model was performing really well. But later, when they applied some kind of interpretability methods, they realized that the model has learned not the wolf as a wolf class, but the features around the wolf, like snow, for example, because in most of the images that they labeled as snow as a common background. What the model did was, if there is snow and if there is a bit of dog features in that image, it's a wolf. But it's nowhere categorizing and localizing that this is exactly what wolf is, right? This is probably the best example to make a user understand why interpretability is important. So let's say you're using it for something very sensitive, something like a radiology image classification, for example. When you feed it a lot of CT scan images, there could be common features for your classes, multiple classes, be it, let's say, cancer versus non-cancer, benign versus non-benign tumor, for example. There could be a lot of features which are part of your benign class, but not exactly related to your tumor, right? For example, when a human looks at it, they'll probably look at what is the lump size, what is the radius of the lump size, how close it is to the tissue, how is it growing with the tissue, those kind of factors, right? But when you're training a model, it doesn't have it has zero knowledge in terms of approaching that problem. You are building something which is purely basis on your labeled examples. If you do not have interpretability as part of it, you are making the model learn, which is actually not part of your problem, but somehow you are relying on it, and later on it can create a huge amount of false positives, which could be really really problematic, or very high risk, high value false positives, which are very much disastrous in nature as well, right? So when it comes to mission critical use cases, interpretability should be used as an audit method to ensure the models are learning proper, and to ensure the model is learning really the things that you want it to, right? Second thing that we realized, actually, if you have the right interpretability method, you can validate your model's conformity and confidence very well. So I'll give you an example, right? Let's say you are still doing same image classification as an example. So you have fed in certain features, and what you realized is model, even though performing well, it confidence scores or it confidence conformity is not good enough. So when you actually do the interpretability of it, you know that, so if your interpretive values are quite slow or quite low, which means the model has not properly learned anything. It simply learned few things on the fly, and you are getting accuracy because there is common distribution values, those things as well. You could also use interpretability as a method to understand whether the model is actually learning the necessary things and also learning properly or not. Right. These are the two things that has been happening for the past 5 years, if not for the past decade, since the evolution of deep learning. For the past 5 years, people have started giving importance to interpretability when they are using things for cases like this. But now what's happening is the interpretability is now evolving as a critical utility in the alignment piece, which is what the next evolution that we believe is an angle of a direction to achieve alignment. Today, you have a classic alignment approach, which is fine tuning, right? So you do fine tuning or SFT or any kind of fine tuning to try to align the models with the behavior you want. But we know that there are many things that goes wrong when you do fine tuning, for example. So the way that we are exploring our research currently stands for the interpretively led alignment is how can I use the information that I could get about the model functioning and use that information to achieve the alignment metrics that I want. For example, let's say I want less bias in the model. I don't want to fine tune it. So the way that we were able to test and seems working as well is using interpretability in LLMs to figure out which neurons or which parameters are inducing or is causing that nature to have more biased outcomes, and you can simply prune them. So for example, let's say I want to remove a gender bias in an LLM today. One way to do that is I'll do some kind of fine tuning to say, okay, here is my classes and all that stuff. But again, you know that it affects your model performance overall negatively in many cases also. So one of the experiments that we did was we used both DLB, which is our interpretability technique, and we used LRP as well as a benchmarking criteria, and then IG. So we have used those three interpretability methods to figure out which layer and in this case, which layer and which part of the network which is causing me the bias, and then we prune them, and we are able to see that the bias is now reduced. The neurons that were responsible for causing the bias can be removed by simply pruning them out also. If you do linear pruning, there could be a negative effects. This is where you may have to do a bit of unstructured pruning. So that's where now there are a lot of new research that is happening around in doing unstructured pruning, where you can identify a specific area which is responsible for that behavior, and you can simply prune them. This as one example. And then on the fine tuning as well. So now the utility of interpretability has gone to a stage where I can do something called safety neuron preserved fine tuning, which means when you build your base model, when you train your base model, you have aligned that model a lot. You have you went through the cycles of a lot of fine tuning on and all that stuff. Let's say your focus was around security of the model. Now when you do any kind of SFT on top of it, it is known that most of your base aligned factors will be lost because you're updating the weights across the neurons in a common sense, in a common way. Instead, what we realized is if you identify which neurons or which part of the layer is important for safety side of the network, you can actually freeze those weights, meaning do not alter them, and update only the remaining weights as required, and you will still achieve near similar performance, but you will preserve all the safety factors of the base model. You can extend that to a lot of new possibilities. But again, so I mean, there are a lot of new directions that we have been exploring and experimenting as well. We have seen a lot of positive, and the industry is also moving in that direction. So utility of interpretability is not just from how can I understand what's happening inside the model. It can go beyond that, like to audit the model, to validate the performance, or even soon enough, you will able to use it to align the entire model behavior as well.
And when you are running a system that depends on a machine learning model or one of these generative AI models, what are some of the ways that you can use that alignment and explainability metric to be able to act as a feedback loop to the actual system to be able to ensure that you are getting the desired performance or that the model is behaving in the way that you want it to be and not having any issues of bias or false statements or inaccuracies?
Currently, we have seen better success as a post-hoc method, not as a training method. So what I mean by that is once the model is done, so I could use it to audit, I could use it to prune, I could use it to validate, but I may not able to use this as a feedback or as a loss function in my system. We tried it like almost beginning of this year. So we thought, can we build a new kind of loss function where I'm using interpretability as a metric? Can I come up with a new loss function which I could use to train the model? Meaning it goes back to a thesis, which is if the model learned properly, then the relevance values or the interpretability values will be really, really stable, rather very much distributed. Can I use that and create some kind of loss function when I'm training the model to say that, okay, you're learning the right things, can I reward you to learn more right things? So this is one experiment that we did, but we realized that there is a problem in that construct. Even though we are generating these relevance values, we realize that sometimes it's a lot of noise than a lot of specific value. So we couldn't quite create these loss functions to focus on exactly the area where we wanted to focus. So this was one problem that we faced in the recent times. Soon enough, probably you will hear from our lab on this research as well. We were trying to do the same thing in RL as well. So for example, typically when you generate, like in your GRPO or whenever you're training the model, the thought process was, can I make the model focus on important part of the prompt, not on the entirety of the prompt when it is doing RL based fine tuning, for example. This we realized it can add certain value, but again, so this is very early in terms of to say, can I expand this as a training, as part of my training process? But as a post-hoc method, this is fantastic. So this is now a new arena where I could use interpretability to align. We also have done an experiment where we are now able to do unlearning using circuit discovery as an experiment. Again, this is a new paper that we are going to publish soon. I'm talking a lot of these ideas. Some of it is published by other reference labs, but again, so most of it is kind of driven by what we do at our labs. So post-hoc, a fantastic new technique and new approach beyond going simple fine tuning. And as part of the training, it's still early. Maybe we will get there. For RL, it could get there quicker, but again, a lot of it need to be tested at scale to say whether this works really or not.
One of the interesting aspects of these types of conversations is that we use a lot of language that seems intuitive to discuss these challenges and use cases, such as alignment. We want to build trust in the model. We want the model to be reliable. But as you try to actually define concretely what metrics correlate with each of those concepts, you very quickly get into a philosophical debate and have to dig through a lot of the assumptions and ingrained complication of language. And I'm wondering if you can talk to some of the ways that teams work through that process of saying, okay, we want this model to be aligned with our overall objectives, but now how do we actually determine what are the metrics that correspond to that concept of alignment within these specific parameters? Or how do I ensure that trust is appropriately recorded and adhered to given the specific use case that I actually have?
So that's an extremely contextual problem, right? Meaning, as you rightly said, so alignment to me is very different. Alignment to you is very different. Unless we agree on certain common metric that we track, it's extremely hypothetical metric and a debatable ideology as well. Again, so we had a similar problem even in interpretability, meaning how you explain the model to, let's say, a data scientist versus to a researcher versus to a regulator versus to a business is very different, right? Even for a business, it's person to person as well, meaning I may want the explainability in certain manner, vis-a-vis with another person may want the explainability in a certain manner, because everybody understands it differently. Everybody wants to correlate with their scheme of things and all that stuff. It has to come to a stage where there is a common evaluation metrics, or else this will not scale nor even evolve from what the current condition is. But luckily, I think we already have certain metrics or data sets that we are looking at as an industry. For example, like let's say you wanted to have model alignment from a safety point of view. So then again, the question is, which part of the safety are you talking about? Is it on, let's say, the safety from child abuse, or is it safety from exploitation of the model, safety from wrong factors like chemical, biological warfare? A broad definitions doesn't work. We have gone a stage 3 years back where the alignment was a debate topic. Now it has to get factual and quantitative, or else it's not going to scale. Meaning, on what metric would you say the model is aligned if you don't specify what do you mean by alignment, right? So the problem definition has to be really clear, and the follow-up validation metrics also need to be clear. In our case, most of these are data driven for us, meaning when we say bias, we try to have a data sets which has the bias that we can validate upon, and then we say, okay, here is a metrics that we use as simple as, let's say, F1 score on for a sensitive class, for example, as my bias metric. It can get very, very simplified, very easy to track to begin with. Once I do that fundamentally, then I can scale up to saying that, okay, fine, is is it aligned to a business requirement, is it aligned to a regulator's requirements from that point of view. Again, all of this can evolve. So I would say the clarity of definition to the point that it's focused on to the dot problem, and a clear simplified evaluation is quite important. The approach to solve is complex enough, so let's not try to overcomplicate the evaluation as well.
And so for teams who are invested in actually collecting and acting upon these metrics and insights of explainability, alignment, interpretability, what are some of the supporting systems that are necessary to be able to operationalize and scale that information and be able to effectively take action on that beyond just the capability of putting in a model into production either via an API or running your own inference server?
I would not think there is maturity in the current process today, right? So, for example, for a very long time, people thought chain of thought is a reasoning, is an interpretability for LLMs. It was so stupid that people thought that was an interpretability method. Chain of thought is simply the prompts that is going in and the prompts that is generated. It never explains what's happening inside the model. If you look at similarly what is scaled from an explainability in a very simplistic for a statistical model, for example, which is very much easy, right? So I have a linear regression, for example, or a linear regression kind of model. It's quite easy for a user to understand, okay, these are the factors that is influencing the model, which is A and B, which is coming out as Y, for example, right? It's very easy. I know what those factors are which can influence the model. I'm not saying I have given this 10 features that is going in and that's how I'm explaining it. That looks stupid, right? If I say, okay, fine, age, gender, occupation, these are the 10 features I'm passing to the model. That's not explainability. That's just model input. The same is what need to happen to current systems as well. So if anybody says there is an interpretability, you better explain what's happening inside the model. Don't explain what is going into the model. If what is going into the model is interpretability, then every system should act in the same manner, right? If not, then there is the model that is influencing the output, which means you have to understand the model behavior as an interpretability thesis. If you're not doing it, if you're only looking at the input, then you're not interpreting the model, you're simply doing the pipeline explainability. But this is not matured yet because it's quite complex to do that for an LLM today. So you have SAEs, which is what people have used to some extent at the moment, but nobody is looking at explaining an LLM as a critical enterprise requirement. But it is now a requirement because even today, people were using it as a human in the loop system or a human augmentation system. If you are going to use that for a very complicated real life expert predictions, what we used to do for statistical systems where you are explaining each parameter, how the parameter is influencing the output. So you may have to do that for this, or else a regulator will ask the same question, right? You are doing that for this model, whereas you are not doing that for this model. You are simply giving me the pipeline explanation. Why can't you do the similar thing? So then, there will be questions around regulations, there will be questions around reproducibility, there is questions around accountability, meaning whom do you account to? If you're explaining the pipeline, then the accountability always goes to the guy who builds it, right? But if the model is bad, then model builders will never take the onus because they can build the model in any manner, but explainability is not part of it, which means they will never be governed nor questioned on how the model is behaving. This is what is kind of getting into a lot of debate between the regulators and model manufacturers, particularly the GPAI, which is general purpose AI models, wherein they are getting into debate with regulators saying that the systems are like this, what can we do? We can't explain and all that stuff. But nevertheless, I think this is where it has to get to. In the enterprise, the pipelines are established for certain modeling techniques like statistical model, classic ML. There are very good pipelines to do interpretability, at least within large organizations, if not with the regulator. But it's very much not developed when it comes to very complex, very frontier models today, because this is very, very new from an industry standpoint. But slowly it will get there. And what's happening on the other end is people are investing a lot on traces, which is observability, and the guardrail systems, for example, which is a good start, which is why many people are investing today, because it's an easiest way to try to do the same thing. It's not full-fledged, it's not 100%, but it at least 10% that you can do with less amount of effort with very, very simple cost. People are able to do trace logins for an agent that is functioning, for example. People are able to apply guardrails. It's surprising that people use agents without guardrails, whereas text with guardrails, it's very surprising. People also should apply guardrails on agents and agents, traces and scratchpad as well. But slowly, that's where a lot of these products are now coming towards to enable that to enterprises. That's why it's not a surprise to see that OpenAI has launched an agent tracing, agent building platform. Mistral has launched an agent tracing platform. So because people know that they have to solve these problems, or else no matter how frontier the model is, it will never see the full potential.
Another interesting aspect of the collection and utility of these metrics as you're building one of these systems is that one of the major areas of focus right now is on building these evaluation harnesses for your model to make sure that as you change the prompts, as you change the data, that you're still getting the overall desired outcome. And I'm wondering how you're seeing teams take action on using some of these explainability and alignment metrics to then be a factor in the determination of whether their evaluation suite passes or fails, and how that feeds back into the design of the prompts and the overall context engineering that they're putting into these systems.
I don't think they are using any kind of inputs from interpretability or alignment as part of the evaluation criteria today. It's a brute force method, right? So again, 20 years back, how we used to evaluate any ML system at that point of time is accuracy, right? You have this set of examples, you see what the model is performing, is it performing well enough in that accuracy and performance criteria, and if it is so, then you say, okay, fine, the model is working okay. Which is, as I said, it's a great starting point, right? So which is what everybody is doing. So they are creating these evaluation metrics, they are creating synthetic prompts, they are creating synthetic eval criteria to try to validate certain metrics. But again, going back to my example, it can classify an image very well. Your accuracy is quite high. It doesn't necessarily mean that it learned the actual features well enough. When things go wrong, it will go wrong quite quickly, quite badly, which happened in the case of OpenAI many times. When they release a frontier model, there was always jailbreaks, there is always these kind of stuff. But again, as I said, so if interpretability and alignment so new, forget about making that as a common metric across the pipeline. It's very much currently specialized or restricted within, maybe for fine tuning from an alignment point of view, and interpretability in some cases, safety specifically for certain players like Anthropic. I'm calling out Anthropic because they are visibly has invested a lot on a mechanistic interpretability and using that as a method to do alignment and fine tuning as well, whereas many other players not so much. But yes, so it's still a very under evolved or evolving area. Current evals is as good as what probably any person would do as a basic 101 exercise. It's surprised to see that it's happening now. It should have happened like from the day you are productionizing the system, but luckily it's happening. Somehow I'm also a little surprised that this topic, evaluations as a tool, gained too much of attention, which was from any AI guy, like an obvious point. It should be the case. Why are you hyping it so much? Like if you're not done it, then you're doing it wrong since the beginning, right? So this should be like a basic 101 thing, should have happened from day zero.
And for teams who are setting up these interpretability and alignment metrics and they are trying to make that part of their core practice for how they actually design and implement these overall systems, what are some of the biggest challenges that they are encountering as far as being able to incorporate them, whether that is because of technical challenges or organizational buy-in or just the integration of these metrics into existing systems, etc.?
Got it. I think the best way to explain this is to categorize the systems. Like, let's say easy, medium, complex, and complex. Easy is all your statistical models, which are intrinsically explainable. And then you have medium complex, which are, let's say, classic ML, old age deep learning. These are medium complex. And complex is, let's say, LLMs, frontier models, those kind of stuff. So easy and medium complex category of AI models, there is a good amount of product maturity there, which is where people have been investing, like banks has invested a lot, particularly from an MRM point of view, which is model risk management point of view, these systems. And it's very much when it comes to complex systems, right? As I said, the interpretability and alignment has never gone into AI engineering phase. It's still part of your core modeling R&D phase itself, which means only the frontier model builders are focusing on these problems because they know that these are important for them to align the model, to make sure the alignment is done right, and for them to release the model they have to have better methods and approaches to align the models or to interpret the models, right? That's why people like Anthropic uses these approaches before or as part of their red teaming exercise before they release the weights of the model or the APIs of the model. So when it comes to complex systems, the frontier companies, the frontier labs are only focusing on this. This is what I was saying. So this itself is quite new in that complex algorithms area. Whereas interpretability and alignment is something that is very productized, and many industries are looking to scale this as a product. and it's easily achieved and consistently deliverable for easy and medium complex AI systems. When it comes to complex systems, it's still in the R&D labs, particularly with the frontier companies. Whereas for easy and medium complex AI systems, there are commercial products in the market, and they will continue to be more effective commercial products in the market, which are kind of scaling in the market.
And for teams that you're working with who are investing in this overall practice of trying to make sure that their models are properly aligned, that they are trustworthy, what are some of the either points of confusion or aspects of education that you have found to be either most lacking or most critical as you're working with those folks to make sure that they're actually getting up to speed and using these insights effectively?
So most of our customers are primarily large financial institutions, regulated entities like financial institutions, insurance, these kind of players. So earlier we were deploying decisioning systems using easy or medium complex AI systems, which enable them to deploy these decisioning systems across multiple use cases with confidence. Because even if I use deep learning today, I can explain it, which means if I'm using deep learning for, let's say, an underwriting problem or a fraud detection problem, I can explain it more detailed in a very truthful manner that is required to a regulator, for example, which means they can upgrade from a simplified systems to a complex system. For very very complex systems like LLMs, for example, most of our work is doing this red teaming as part of our internal private LLMs, meaning these banks wants to use LLMs which are more aligned, safety in control. They want to have the endpoints which within their environment, weights within their environment. For them, able to deliver this at scale, which is alignment and safety, is quite important. So those are the customers whom we work with more and more. I think we are seeing more amount of demand for that, where people are now more interested in creating their own private LLM endpoints, because they know that open source have caught up with private systems, and you can actually match or even exceed the performance when you do certain things really well, which is fine tuning and then these kind of stuff. But they want to ensure that these open source models that they use, they have a version of them which is more safer, more aligned, more ready to use. So those are the kind of customers where we work with. In a way, we are kind of launching a frontier model specific to an enterprise by applying these approaches and many new experimental approaches as well. So there are value adders, how well we can come up with new approach, and at the same time how well we can adapt to any new technique that comes up in these areas.
And in the context of building a frontier model for these types of use cases, how does that relate to patterns such as LLM as a judge, where you're using a model as the interpreter of whether the model under test is actually performing in the way that you want it to?
That's a good evaluation tool, but it's neither an interpretability technique nor an alignment method. So you can scale up your evaluation criteria and approaches. There, we do not have any caveat. So we always take in the download from the community in terms of what works and how well I can evaluate. But when it comes to fundamentally fixing the problem, so in evaluations, you are finding a problem, right? You are not necessarily fixing it. In interpretability or alignment, you try to fix the problem by doing, let's say, ASFT or safety fine tuning, for example. So these can, or unlearning or pruning, all these new methods that we want to find a more robust fixing these fundamental challenges with the foundation models, while the evaluations and evals can always evolve from time to time anyways.
And as you have been working in this space and working with customers, what are some of the most interesting or innovative or unexpected ways that you've seen teams either collect or apply these various methods to understand the operation of their ML and AI systems?
Yeah, so one of the common things that we have seen in the specifically in large organizations or highly regulated organizations is, as I said, so even if you take an example of an interpretability, right? So in interpretability, which leads to creating an explanation, which is very much a user specific, which means when we were doing this for a large organization, they would say that, so I'm explaining this to be part of my explainability for a prediction. And another user, which is primarily a regulator, will say, okay, no, I want this to be part of my. So we have created something called an explainability agent, It's nothing fancy. It's as simple as a common engineering thought process, right? Where you would say, fine, I'll collect multiple artifacts from the base systems. Meaning we have used DLB, which is our technique to try to do interpretability, which creates a bunch of artifacts at token level and for all the tokens in the answer as well. And then we combine that with multiple other methods, and then that coupled with the model behavior at that time, meaning we try to track the model performance like drifts. Was there any drift in the data? Was there any deviation in in the inferencing inputs? We give that information also. So what we necessarily created is an exhaustive explainability agent, which will take a lot of information from the base engineering platform that we have, which takes the explainability outputs, model telemetry, and the process telemetry as part of a single input to create a user specific explainability outcome for each prediction, which is as simple as when a user logs in, basis on the user background, the explainability changes because you now have an agent which can convert that information for you in a very simplified manner that you can understand and you can consume it. So these are like very simple things from an engineering standpoint, but extremely useful to an end user, because no point for me to create an interpretability output which are like extremely complex information if a user doesn't understand that information. That is still becomes a gibberish to the user, right? This makes it very easy for us to not only be technically grounded, but also use the agent to be able to bridge the technology gap or tech language gap basis on the end user. So that seems to be working really good for us as well. So sometimes some of these simple things can scale up really good.
And in your own experience of working in this space and doing research on appropriate methods and effective actions to take based on the metrics you collect for interpretability and alignment and trust building, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
Got it. So again, so our thesis, when we started, our thesis was largely on the interpretability and interpretability led alignment. What we are doing in the last 6 months had been a lot of frontier work. So we are using the observations from the interpretability in multiple things like safety neuron fine tuning, for example, or using that information to do pruning to induce a behavior. We also used a similar approach to compress the model as well, meaning to typically compress your model, you do things like quantization, or you do a PEFT kind of fine tuning, those kind of stuff, right? What we realized is sometimes you can simply prune the neurons to zero, which when you build a neural network, you build massive amount of overload. Not all neurons are used when you train the model. You can simply run a task and you know which neurons have been really useful for you to execute the task. Not exactly, I don't think this maps with the activation maps to that extent. In this case, we are able to understand that by calculating the relevance of each neuron or each layer to figure out is that neuron is actually relevant for you or not, and simply prune them. So we are able to reduce the model size in one example where we published a paper in Mikai where we were able to prune a simple CNN model also by almost 40%, 40% less number of layers, params, and still have near similar performance, which means I can actually compress a model and still maintain same accuracy or still maintain same performance, for example. So some of these had been really interesting. We know theoretically these are the things it should be possible if I could do it. In the last few months, this is what we have been executing upon and building upon. I think our what we are trying to build as a tool also is something like we call it internally the project name as AlignTune, where the project is primarily to create a CRISPR style a gene editing kind of tool where you can not only identify the neuron that you wanted for your behavior and use follow on things with it, which is pruning as a strategy, or fine tuning as a strategy, or unlearning as a strategy, or you can merge multiple models into one model as well. So this is what we are currently working on as a project, like a massive, large project. It has not done ever in the current industry scheme of things. It will take some time for us to release it, but when we release it, it will probably be one of the frontier things to be done. You will have a model editing like a gene editing where you can have your induced behaviors and edit inside the model, not just outside like guardrails or evaluations, and then do follow on things with it to further refine that behavior more and more. So this is what we are very, very excited to see to come out very soon, is what we are hoping to deliver.
And with that capability of identifying and pruning neurons that you don't care about for a particular use case, how do you see that impacting the overall efficiency and compute requirement of these models and being able to drive down the cost of operation?
So as for whatever we have done so far, the results were super positive in terms of, okay, if I reduce, let's say 20% number of params inside my model, which means it can directly help me to speed it up. Even 10% efficiency for a billion calls is like massive value add from a bottom line perspective. And from overall performance also, so it depends on how much you want to prune. For example, we have seen 20% is a very comfortable pruning threshold. Somewhere between 15 to 20%, there is almost zero loss in performance. It also depends upon what is your pruning method, as I said. So are you doing linear pruning or unstructured pruning? It depends on that also. And also the quality of the samples. There's a lot of hyperparameters around it which will influence it, but you can easily do 20% pruning really well. If you want to go from 20% to, let's say, 50%, for example, that's when things get really, really complex, because 50% pruning meaning you are going to remove 50% of your neurons or layers, which will have unintended effects eventually, right? So that's a very, as you prune more, you will have more unintended effects, which is what you probably need to evaluate a lot on different angles to ensure you're pruning the right. But as a strategy, this is quite scalable, is what we believe. We have already demonstrated on the base set of models. Now we are scaling that to a larger model with different kind of approaches. Possibly as when we get there, maybe you can able to prune really well and be really efficient with zero loss in accuracy is what our goal is.
And for teams who are deciding whether and when to invest in this overall capability of evaluation of the explainability and alignment of their models, what are the cases where you would either say it's overkill or advise against it, maybe because they're not far enough along in their overall maturity curve for AI capabilities?
Got it. I think from an importance or scale of importance, this has to be done at a foundational model level anyways, because you are going to distribute that to n number of users where you may or may not have control. Both in closed weights approach or open weights approach, you do not have control on the end use case, which means fundamentally it's quite 100% important to do that, which is why most of the frontier companies differentiate upon the alignment metrics, right? Like instruct values or alignment values, for example, they get differentiated on it. When the performance difference is point decimal in percentage points, some of these things becomes really critical for an enterprise to look at, and that's one of the reasons why Anthropic is winning in the enterprise market, right? Because they're very serious in terms when it comes to model security and safety, whereas OpenAI is in many cases liberal in some of these aspects. I would say when it comes to when releasing weights or a foundational model weights, this is 100% important. A criteria is quite high, and if you're using it for any sensitive use cases and regulated use cases, this is 100% important, because that's not a choice, it's mandate. You cannot change it. If you're not doing it, then you are violating the law. Some regulator, some customer will sue, and then you are in a big mess. It's an overkill where the use case is very liberal or linear, meaning if I'm using it as something like maybe a calling agent, something of that sort, it's okay. You not doing it to the 100%, maybe you will still do it to ensure there is no bias, meaning your calling agent is not racist and calling people and saying that random things. But I would say it's all depends on the use case curve. As the use case gets sensitive, it's the importance to do this is closer to 100%. If the use case is less sensitive, the importance to do this may be 20%. I would not call it zero, meaning you always have to do alignment and interpretability. If not, then you will not need guardrail systems anyways, eval system anyways, which is not the case. You will, when you're using some AI system, you will have some kind of guardrail, some kind of eval. Likewise, you use some kind of interpretability, some kind of alignment tactic. It may not be true to the model, it may not be scalable, but as the use case get sensitive, complex, regulatory heavy, involves loss in life kind of scenarios, then it becomes 100% important that you are doing these things to the fullest potential, which is where there is a lot of enterprise value to solve these problems.
As you continue to invest in this overall space, what are some of the things you have planned for the near to medium term, either in your own work or maybe some predictions or requests that you have for the overall industry?
Yep. So I talked about the AlignTune project, right? Like that's a massive project that we have, massive R&D project. We have segmented that into multiple sub projects, which is where if you see our research papers, for example, so we have already published a few papers around pruning, which where we are able to validate and demonstrate the approach well enough. Soon you will see things around again pruning as a strategy to fix bias or to do unlearning. Few papers are going to come very soon in that direction, and then we have something around fine tuning, which is safety neuron fine tuning, where certain labs in China, for example, like Shanghai lab, Tsinghua lab, for example, they have done some work in that direction. It looked very, very interesting from their observations as well. Soon enough, you will see more papers coming in from that point of view as well. So we divided this AlignTune as a big R&D into five different R&D projects, which is where we are doing a lot of work, and then all of it will get consolidated into the tool when we release it. It will be an open source tool, so that the community can use it, more so to try to use more advanced methods in a very democratized manner. And the predictions point of view, I think this will now become super critical. It's already become super critical, as I was saying, for frontier models. Like, you are releasing an open source models, the geographical regulations are now kicking in certain geographies, like EU AI Act in Europe, which means if you're releasing any kind of GPI, general purpose AI models, you have to be compliant on certain things, which means, again, it's not a luxury, it's a mandate. So I hope people will start investing on this direction more and more, the interpretability led alignment. Whereas alignment as an area, there is enormous amount of attention around reinforcement learning side of things, around fine tuning side of things today, maybe more than what it should be, but suddenly it's now the big theme of R&D for many people doing things around reinforcement learning, which is the case for us also separately, which is where we have an RL team working around new kind of RL techniques. I think we will see more new RL techniques which are more efficient for sure, which every lab will able to propose new methods. We will do ourselves as well for sure, very, very quickly. Interpretability led alignment or that direction, there are few labs who are doing very great amount of job, like Anthropic, Goodfire. These guys are doing very good amount of job on that direction. But alignment as an area of commercialization, I believe we will start monetizing it in the next 6 to 12 months, wherein how you have been seeing things like guardrails, evals, getting that commercial adoption, you would see a similar story for interpretability and alignment, as when these can able to deliver stabilized, consistent, scalable value going forward, which is where probably the industry is going towards too as well. So that's what my hope is. But otherwise, I think labs like Thought Machines, for example, or SSI Lab, are kind of building upon these themes anyways, right? Which is what I was saying. So the foundational models differentiate basis on multiple things. Performance is too narrow term right now. Usability is now where they are differentiated. For usability, solving these things is quite important. If I say that I'm as equal as, or maybe 1% less than OpenAI, but I'm really aligned, I'm really safe, I'm really, really sophisticated, people have more preference to this, particularly on the enterprise side, even though you are 1% less than the industry leader. But if you're usable and acceptable, you will get more scale, more money in the business anyways. Yeah.
Are there any other aspects of the work that you're doing at Arya.ai or this overall space of explainability and interpretability and alignment and trust building that we didn't discuss yet that you'd like to cover before we close out the show?
I think one last thing that we have not touched upon too much is on the AI risks. So again, to a broad extent, risks can be part of the alignment story that we are building as well, like the safety neuron fine tuning, all that kind of stuff. But what necessarily is happening is these models are not as simple as 10 years back. Deep learning was a complex model, so they are very hard to interpret, understand, or build upon. But what we are seeing now is like a huge complexity. In fact, most of the problems that I said is probably works really well on one modality. When you start combining modalities, let's say you have any to any kind of model where you have both image coming in and text coming in, which is still okay. But if you're building something like world models today, like Fifi is working on world model, Meta is working on world model, Google is working on world model. In that case, the problems around interpretability and alignment is like massive. I don't think we would have the capacity to able to solve those problems ourselves. This is where our next bet is, wherein I think we soon enough, maybe ourselves or someone else, will have an AI to do this, not a human driven approach, which can identify a problem and fix the problem rather we doing it. Then it's a matter of how much we can enable that AI to be able to do this job, right? In a very simplified problem of the similar scale is something around cybersecurity, which is fine. So you have a system. Now you have an agent like OpenAI security agent or Gemini, Google security agent, which was launched very recently, have a similar approach, right? So you have a system and the agent should figure out what gaps are there in the system and should fix it, and or should continuously defend it, right? You take the same thesis to an AI as well. So you have a frontier model and the AI should able to identify the gaps inside the frontier model or inside the AI solution. It should be able to fix it, or it should be able to defend it, during the inferencing. That's the scale that we are talking about. So if your blue pill is your foundation model, your red pill or the safety net is not a software. It's probably an AI that plays this role. I think it's important we should build it quicker and sooner and catch up with the foundation models. So yeah, that's like North Star vision for us that we have in terms of getting there.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'm interested in your perspective on what you see as being the biggest gaps in the tooling, technology, or human training that's available for AI systems today.
No, I think people are getting smarter anyways, right? So in one way or the other, they the only okay. So I have a very, it may be controversial as well. So I'm not too favorable to vibe coding. I mean, it's good to get started for sure, but it's not good to be an Excel art. It builds a lot of redundancy slash laziness, if that's the right word. So typically, what happens is when it comes to debugging, right? You will learn a lot during debugging than building. That's what I believe in many cases. If when people use things like vibe coding to do that, so the debugging becomes very sparse, which means your ability to do debugging becomes less and less obvious, which is what many people were complaining about as well, right? So it takes 30 minutes to build through vibe coding and one whole day to figure out what went wrong. So that's the case. But nevertheless, I think so the information is so much out there, and the consumption is also getting smarter. Smart people will always find the smart tools to figure this out. It's a matter of building those smart tools, and the habit of using them more often and more rightly than ever would differentiate many people. Yep. So that should be the case.
All right. Well, thank you very much for taking the time today to join me and share your insights and expertise in this overall space of understanding how models work and the decisions that they make and how to apply those findings to build better ML and AI systems. It's definitely a very interesting and obviously very important aspect of this ecosystem that we all find ourselves in now. So I appreciate all the time and energy that you and your team are putting into that, and I hope you enjoy the rest of your day.
Thank you, Tobias. Pleasure being here. Looking forward. Yeah.
Thank you for listening. Don't forget to check out our other shows. The Data Engineering Podcast covers the latest on modern data management, and Podcast.init covers the Python language, its community, and the innovative ways it is being used. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at aiengineeringpodcast.com with your story.